We do a lot of mechanical fabrication modeling at holo-blok, which involves taking mechanical design models and adjusting them for constructability in collaboration with trades. So sometimes we'll start off with the model. I just have a very simple sample model here where if we look at a section of a corridor, it might look something like this because the design teams are building for legibility on drawings and often just don't have the time and resources to properly clash everything. Plus, when it comes to actually building the thing, there's always going to be changes required for construction. And that's where we come in to do that fabrication modeling to sort out all these types of issues. But it can be time consuming because we need to ensure that ducts all have a acceptable clearance from the lowest structure, and it's not always immediately obvious where that is. So we have to kind of look along the length of each duct run to see where the lowest structure is, and then ensure that that required clearance is provided. This is a bit of an exaggerated example just to make it extra clear, but we have a bunch of structure shown here where one is deeper than the other, and that might not be immediately obvious. And the problem gets more time consuming to diagnose in much larger models. So we spend a lot of time adjusting ducts so they're a certain offset from the structure above, and then adjusting pipes so there are certain clearance between the ducts and the pipes. So we've decided to automate this workflow where now I could just select all these ducts and pipes and click on this vertical positioning button, and everything's going to shift right to where it's supposed to be. We'll see why this is happening in a minute. But just like that, we'll see that if we pull this section back a little bit so we can see that taller structure we were looking at, we now have 6 inches clear between the structure and the ducts, which also accounts for insulation. This duct has insulation on it, and that's added into the calculation. And 4 inches between the underside of the lowest duct and the pipes below. We can also toggle the positioning of those pipes very easily, where depending on whether we have the support above the pipes or below, we can very easily adjust for that. But we usually need to tighten these up quite a bit for constructability and tighten up ducts a little bit as well. So now what we can do is select all of these and click on adjust horizontal spacing. Right now we have the value set so that there are 4 inches clear, or sorry, 8 inches actually, between ducts. This can all be configured. And 2 inches clear between pipes. And the nice thing about this is it also takes into account that insulation value. If anything changed for some reason, pipe changed in size, we don't need to spend a bunch of time fiddling with things to get the spacing right. We can just click on that again, and that spacing will update to what we want it to be. Also, we usually want these to be given distance from a wall. So let's say we want these to be the minimum acceptable distance from either this wall or this wall. We can select all of these and click on distance from boundary. Just select the wall, and they're all going to shift over, where right now we have the set so that there is 8 inches from the duct to the wall, 4 inches from the nearest pipe to the wall, but that could also be configured. And if we don't want these all aligned to this wall, we could even select a few pipes and say this duct and set those to be spaced from the wall on this side. Also, looking at plan, it's pretty common where we have a branch coming off of a main duct run where we want to hug this up to the nearest structure above as it branches off. So I can also select this and select vertical positioning. That'll shift it up to currently set to be 6 inches clear of the structure, and then easily adjust that or connect that back into our main run. We're using this for fabrication modeling, but it can also be useful for mechanical design teams who want to be proactive about tightening up their models and ensuring that their main duct runs are clear of structure rather than having that come up in a clash detection meeting or going missed altogether.